Okay, so good evening, everyone. Okay, so this is plan 252, yeah, transportation modeling. Okay, this is the agenda for today. So first, let's introduce each other. I know one of you, but the others I don't. So please tell about yourself, okay, your background, your maybe your strength and weakness, and then maybe if you have some wish list or life purpose, okay, and what motivate you taking this course, okay, and what do you expect to learn from this course, okay? And then we will discuss the course syllabus, and I will introduce about urban planning, design, and growth. And then we will discuss about land use transport interaction. Okay. So if we have more time, so we can discuss about basic modeling. Okay. But if not, we will just postpone this for next week. Okay. And in the first hour of our class next week, so you will have a quiz based on what we discussed today. Okay. Is that okay? Okay, so tell about yourself. You can open your camera. Yes. Go ahead. So who will do first? Okay, me. I will do first. Okay. Let me introduce myself. Uh, what is okay, my screen. Ooh, yeah. Can you see my screen? Okay, so this is when I was still very young. Okay. Okay, so uh, my name is Karti Teknomo. Okay. So Teknomo is my family name, but I created that name. No, my father created that name. But my father's name is not Teknomo. Okay. So he loved technology so much, so he forgot to put his own name in the birth certificate. So that's why the first Teknomo was born. Yeah. Yeah, hello. Uh, It comes from technology and nomo is name in Japanese. Okay. So yeah, this is my father. So I was born and live in Surabaya. So I married a Filipina. Okay. So these are two children. So I work mainly in Indonesia in Petra Christian University up to last July. Okay. And then also work in Saga University in Japan. I also work in Vienna for 2 years, in Austria. In now they call it Austrian Institute of Technology. At that time, the name was Arsenal Research. Okay. And then I also work in Wisconsin, yeah, University of Wisconsin, teaching there. And for a long time, I worked in Ateneo de Manila in Quezon City, and also for flying professor in Davao, Ateneo de Davao. And since 2023, I work in UP. Okay, so right, so yeah, now we have four technomos, yeah, critically endangered species, right? Okay, so this is my hobby. So my hobby is research, mathematics, programming. Okay, so very rare hobby. Okay, and yeah, I like reading, writing. So, and across more than 35 years, so I have many different type of lecture from operation research, simulation, business modeling, okay, including physics in complex systems and spreadsheet, GIS, okay, computer science, and mostly also in urban transportation planning. Okay. Uh, I also teach in industrial engineering. So it's a bit strange combination. Okay. So practically all around. I also write a poem and publish it in certain books. Yeah. Anyway, so this is my research interest. So basically, still, even with various backgrounds, so I still focus in urban spatial model, urban and farm traffic, yeah, especially pedestrian behavior, yeah, using mathematics. Yeah. So this is my website, okay, revoledo.com. Okay, and these are a few models that I developed uh, in '99. Okay, I developed also micropad sims and a few other models. Okay, so these are micropad sims that been developed. So today I will discuss later about the urban growth model. Okay, this is when I was in Japan. Okay, so I don't know if this is still alive, but you can search this Ethan model also. Yeah. And in computer vision, okay, I developed what is now called Technomo-Fernandez algorithm. Yeah. Oh, I have an algorithm of my own, my name. Yeah. Okay. So anyway, it's basically it's quite old anyway. So it's 99, 2006, I think. Yeah. So, and I developed how to model from OD to trajectory. So this is mainly my research. Okay. And with the OST, last time we developed also traffic.org. I don't know if still alive or not. Okay, in Metro Manila. And then I also contributed to create what is called queuing rule of thumb, yeah, QROT. So again, this is my some of my contribution in the world. Okay. And the last one, this is the one, the main part that we will discuss at length in this course is ideal flow network. Okay. So this is what I developed and I created IFN transport. Okay, and ideal traffic assignment. Okay, model. So yeah, with Toyota, I developed this traffic accidents in 12 years in Metro Manila. And these are my some previous projects. Yeah. And so until now, I'm still part of the board in Savannah Simulation in Switzerland. Before I was also part of the project, yeah, in Blackthorn, in Brazil, and also in the World Bank and Toyota. Recently, I worked for Decathlon France and so on. Okay. Anyway, so yeah, that's all about myself. Now about you. Go.
I'll
uh,
go first. Okay.
okay,
Okay.
go, please.
Okay. Thank you.
Okay.
Um, I'm Blaise Morales. I'm currently working for a real estate company um, as in corporate planning. So my strengths are I can do modeling, mostly financial modeling,
Mhm.
and weaknesses. Um, hmm, I guess transportation. I haven't really studied much before.
Okay.
I know some of the principles behind it, but I'm 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 taking it as a penalty course.
Oh, okay.
So yeah, so I'm currently doing my thesis and waiting for my 10-year data to complete by this year.
Okay.
Um, my wish list in life is I hope to help develop cities. I hope their cities in the Philippines would be more efficient. So that's my wish list that we can also
Okay.
have good transportation in Manila.
Okay.
And my life purpose is to help people plan. So as a planner. And then my life principles are I like um I like what Daniel Burnham said when he said that we should uh, first think about the make things rational and beautiful, and then if you make a rational and beautiful diagram, it lives beyond us. So I guess there's a legacy when as planners, even if we don't see the plans happening, if it's rational and beautiful, um, it can even go beyond politics. So what motivates us taking course of this program course? For me, I really love modeling, and then actually I see how traffic impacts retail and and the viability of retail properties. So my interest in taking this course is one, seeing how it can enhance retail and um, in malls and what makes it more viable, and how to make retail properties more viable, like malls, etc. What I expect from the course, I went through some of the materials already, and a lot of math, um, the pedestrian trap, and then it's very interesting theories that I still want to practice, and some of the math I still can't get, but I hope to go over this with Sir Professor Cardi. Yeah,
Okay.
that.
Okay, go. The other one. Who will first? Introduction about yourself. Aaron?
Hi, good evening, everyone.
Okay.
So, about myself, so I am a professional with a decade of experience in GIS and mapping industry. So I am deeply passionate about how spatial data and urban planning principles can be applied to solve real-world problems, no, particularly in improving transportation and mobility in growing cities.
Mhm.
So for my background, so my academic foundation includes a Bachelor of Science in Geography and a diploma in urban and regional planning. So currently, I am furthering my education by pursuing the MA, no, in urban and regional planning, also specializing in transportation planning. Yeah, so as mentioned, professionally, I have spent the last 10 years in mapping industry. So I currently serve on the geo products of map operations team at Grab Philippines. So where I lead three critical units no in mapping. So the consumer maps, country support, and the navigation teams. So for my strength, probably my GIS and mapping skills. As for my weakness, actually, in the past, I sometimes struggled with delegating tasks as I have a high standard for precision in mapping work. So, however, I learned that effective leadership involves trusting my team and focusing on mentorship. But anyway, um, wish list in life. Well, my wish list in life is to contribute to the development of smarter, more sustainable, and more equitable cities, no, in the Philippines or even in Southeast Asia, if possible. So, purpose in life. My life purpose is to leverage my knowledge and skills, not to create tangible positive change in my community. So I aim to use my expertise in geography and planning to help build more efficient and people-centered urban environments. No. Next is, what are the life principles that you hold? Um, well, continuous improvement, no, both personally and professionally. So I believe the power of always learning and adopting. And then what motivates me taking this program or course? Well, actually, this is also my penalty course. So, but I am motivated no by again my strong desire to formalize and update my practical knowledge with the latest academic theories or methodology related to transport planning. And lastly, what do you expect to learn from this program or course? So I expect to deepen my expertise in transport modeling, no, sustainable urban mobility policies, and data analysis techniques as um, this is also critical in my line of work. I hope also to gain new frameworks for tackling traffic congestion, no, even improving public transportation integration, and basically enhancing the overall user experience and navigation and mobility platforms.
Okay, good.
Thank you.
Thank you. Thank you. Who's next? Ken?
Okay, good evening everyone. Magandang gabi. So I'm Ken Adrian Arakan. Similar to Aaron, I'm a GIS professional. So more than 10 years, almost 15 years of experience in mapping and GIS. So currently working on a freelance basis. So whenever there are um, projects coming platforms, I grab them. So I'm a graduate of PS Geography from Diliman, currently a diploma student taking this subject as an elective. So I took this course basically to widen my horizon. So aside from GIS, most of my work, professional experience, is centered on disaster risk reduction and management. So I wanted to have a different uh, subject to learn to. So I'm very much, I think I have exhausted learning on the topics of DRM. So I wanted to have a deeper appreciation of other um, topics that would uh, deepen my understanding of the world. And I think transport is very critical when it comes to disaster risk reduction and management. So, uh, strengths and weaknesses, I am involved in mapping. So, I would say that mapping and spatial analysis are a few of my strengths. Weakness is, I think, when it comes to um, some mathematics topics, specifically certain topics, because I had a hard time before in engineering mathematics. So that's one of the
Okay.
things that I have to work on. And then wish list in life, I think I would want to have a safer communities as well as cities and communities that have access to efficient and economically accessible options like for transport or for social services. And then what are the things that uh, I'm sorry, what is that? What are the life principles? I think um, the humanitarian principles working in the RRM has uh, deeply affected my life, that I wanted to help more people as much as possible because I've seen firsthand how um, disasters and emergencies can affect one's life. So I wanted to use my technical skills in order to improve on our services. And what motivated me to take this course, I already mentioned that. And then what do I expect? Programming. I would expect more exercises in programming, and I wanted really to
Uh,
sharpen my skills in programming because it had been years since I have practiced on my programming skills.
okay. Oh, who's next? Mr. Buena.
Hello, good evening, everyone. Um, my name is Dennis Buena from Quezon City, and I am married with three small kids. And my hobbies are on weekend I play lawn tennis, and weekdays sometimes if I have time I do play pickleball and do jogging. And I have my undergraduate course is forestry from De La Salle Araneta University. And right now, I'm taking up masters in urban and regional planning, specializing in environment and natural resources planning. I'm not into the transportation planning tracks, and this is my final year in UP.
Okay.
So hopefully, I can finish my thesis next year. And currently, I've been working in NAMRIA for over 20 years now. NAMRIA, or an attached agency of the DNR. This is the National Mapping and Resource Information Authority, as a senior remote sensing technologist. and and I have some of my trainings include of aside from GIS and remote sensing, I also do disaster risk reduction, integrated watershed management planning, forest land use planning, and comprehensive land use planning.
Okay.
So my strengths are, of course, the GIS and environmental planning, and I'm a team player, and I am very patient. And my weakness is mathematics, but I believe that with your help, sir, Cardi, and with the different applications, I think we can overcome that.
Okay.
And my wish list in life include, well, of course, to have a good future for my family and to live longer so that I can enjoy and help others and play more tennis. And of course, finally to travel the world. Um, what else? Well,
Yeah.
my principles, my philosophy in life. I think in order to enjoy life, I do believe that we need to minimize pain and maximize the pleasure, and do the most good to everyone. And okay, so what and what motivate me? Well, traffic congestion is a pervasive issue in our urban areas, and as an environmental planner, I am frequently approached to offer potential solutions for proposed land use developments. My motivation for taking this transport modeling course stems from the desire to become better equipped with relevant ideas, especially on modeling part that I can share with my colleagues, clients, and friends, and ultimately contributing to more effective and sustainable land use planning. Thank you, sir.
Thank you. Thank you. Who's next? Uh, Lian? Lian?
Hi, can you hear me po?
Yeah.
Yep. So hi, I'm Lian May Balagtas, and I'm a graduate of civil engineering in UP Los Baños, and I'm currently working as a drainage engineer, and my projects are mostly Australian projects, so and a private consultancy firm. So my strengths and weaknesses, I think my strength would be calculations and mathematics. I actually love doing it and design. So mostly that. And my weakness is more on writing, like writing papers, research. So that's my I can say that's my weaknesses. And my wish list in life, well, I would like to travel the world as same as your Buena there. And also I would like to somehow contribute to the transportation system in the Philippines because I think we have a problem with transportation right now. My life purpose, I would have to be honest and say that I think I'm still searching for that right now. I believe I'm still young to know what that is, and I want to explore more things to be sure what I think my life purpose would be. Um, Current life principles that I hold is integrity and personal growth. So I believe that whatever happens, especially with the context right now in the Philippines with the government, I think we have to strive for integrity, for honesty in everything that we do. Even if living here in the Philippines is hard, so we have to hold true to our principles and also personal growth, like keep making progress, and yeah, especially right now. And um, what motivates me from taking this program or course, because currently my work mostly involves with water drainage, but I really want to have a career in transportation. So I think this is one way of um shifting my career to that path. And yep, I basically just I'm really interested in transportation, and I want to learn more about programming. And so I can also answer the last question by that. Like, I am expecting that in this course we would be hands-on and actually working on projects or on simulations that involves transportation. Yeah,
Thank you.
thank you.
Justin?
Hi, good evening, everyone. I'm Justin Asigawa, and despite what my last name says, I am not a Japanese anymore. I
Okay.
guess I'm in 1 in 32nd in my lineage. I am a civil engineer, and my profession is that I teach at the State University where I reside, Tarlac State University. I teach civil engineering subjects. My strengths, I guess, is that I am capable of taking in a lot of information, and I can, but I guess, process it in my own way. And my weaknesses would be that I can sometimes be stubborn when I do when I do something, I do it my way, I guess, something like that. My wish list in life is, I guess, similar to what the other two have said, which is to travel and I guess be more exposed with different cultures around the world. And same with Lian. My life purpose is, I guess, still pending as of this moment. It's still too vague for me to identify it right away. My life principles is, I guess, just come what may. Whatever happens, happens, and it happened for a reason. So I'll just accept it and deal with it in my own way again. So what motivated me to taking this program and this course is that uh, both for personal and for professional reasons, I guess. For personal is I have been intrigued with the planning and most specifically transportation when I was in my undergrad studies, and I want to take it further higher. And with regards to professional, we are the department of civil engineering where I work is trying to expand its disciplines. Currently, we only have structural engineering in our college, and we want to expand it to have transportation engineering as well. So that's the professional side. That's why I want to take it. Um, Lastly, what do I expect to learn from this program and course is, well, uh, to pass. But mostly, to gain more knowledge about transportation modeling and its other relevant
Yes.
studies as well. That's all.
Thank you. Yeah. And who else? John? Yeah. John Kenneth was my student in previous class.
Yes,
Yeah.
in 258. Hi,
Yes.
sir. Hi, classmates. I'm John Kenneth. I'm from JK. I graduated back in 2020 in UP Diliman undergraduate course.
You'll need to unlock your iPhone first.
My undergraduate course was Bachelor of Science in Community Development, so I have a deep understanding of social frameworks and other community development principles. So currently, I work as an infrastructure advisor at PwC Philippines, where we assist mostly government clients in transportation and other large-scale infrastructure projects. My strengths, my strength, I believe, is that I'm really good at research. I like writing. And then on the other hand, weaknesses, I don't really have a very good understanding or rather background in mathematics, so I might need a little bit of help in understanding those things. Uh, uh, for my wish list and my life purpose, I think it can be they're a bit tied. I want to contribute in the institutionalization of transport-oriented development here in the country. Because currently we don't really have a robust sort of guideline, or currently it's just a framework for TOD. So I want to help in formalizing that. Uh, Life principles, I believe in continuous learning. I think that growth doesn't stop in the classroom. I think that it's all about being open to new things and being adaptable. And learning can be gained from our experiences and the people we work with. What motivated me in taking this program or course? Uh, Modeling is something that uh, is always used in our line of work, and I want to expose myself more in that line of in that field. I expect to learn modeling, of course, and how it's used or applied in real life situations.
Okay. Thank you. Thank you for all your introduction. Okay. Now I would like to discuss with you about the course syllabus. Okay, let me open that slide. You can also follow this course syllabus in Moodle, yeah, in Revoledo. Can you open your own slide in Revoledo? Let me show you the screen. Okay, so this is our agreement in this class. Okay, so this is my email. Okay, when you email me about this subject, so please put this code in the subject so that I will know this from you. Okay, and this is my WhatsApp, still in Indonesia. This is my Facebook if you need. Okay, and you can also consult with me anytime. Okay, 24 hours delay expected. So even if you contact me at night, I don't mind. Okay, but expect that I will reply to you in the next 24 hours. Okay, so this is our class schedule. And okay. Before that, can we appoint one of you to be the beadle? Anyone want to volunteer? So that when I contact one of you, so the beadle, and then the beadle will contact the others, just in case. For example, if there is some disaster in the Philippines, I don't know, right? So you need to tell me. Yeah. It always happen. There are some top storm and the class is canceled. I don't know that because I'm not in the Philippines. So you need to tell me. Anyone want to become the beadle? Volunteer, the contact person. Are you still there? So, hmm, okay. Aaron, is that okay with you to be the beadle?
Yes, Prof.
Okay, thank you. So I will give you the contact for others, contact number for others, okay, their email, and then you can ask their phone number. Okay, thank you. Okay, okay. So this course offer an applied approach for transportation planning and engineering. So mainly about mathematics. Why we do more mathematics? Because of the precision in the mathematics. So don't feel bad if I talk more about mathematics in this course, okay? But because when you deal with the mathematics, remember this, yeah, you are talking about the precision, the rigor. So, for example, when you talk about planning, okay, so when we talk in the rigorous way, then you will know, oh, what is the sequence? Okay, what is the actual plan that we want to do so that it can be repeated by other people. So it's a kind of language that we can deal with uh, various policies in this course. Okay, and I have developed the software, so you will not do programming. Okay, so no need to worry about that. Okay, if you want to do programming on your own, that's fine. Okay, but the mathematics is there. Okay, and the mathematics I developed it by myself, so that means it's probably hard for you. No problem. That's why I'm here. So you need to tell me which part is hard. Then you tell me, okay, that this is hard. Okay, please explain more. I can explain more detail. Okay, so next, this is about the transportation supply and demand modeling. So if you're undergrad or previous subject about transportation, mostly they talk about demand modeling. But in this course, I will talk more on transportation supply. Okay, yes, I will still discuss about demand modeling, but more on transportation supply. Why? Because based on transportation supply, then we can intervene. Okay, we can get the policy to change. We can guide the future. Okay, okay. Yes, with the demand, we will know the demand. Okay, but that's mostly on operational. Okay, so we'll deal with the application of the algorithm, not the algorithm itself. Okay, and then you will create what is called basic scenario, a baseline scenario. Okay, and then you will create also the alternative scenario. Okay, and then you compare. Simple. Okay, so we will discuss about macroscopic and microscopic simulation and design a transportation system. Okay, but the most important here is to create the policies. Okay, to intervene on the infrastructure in the service network that you have. Okay, and then you can also implement certain mobility policy. For example, bus. Okay, operational. Okay, what we want to transport is not the car, but the people, isn't it? Okay. So the ultimate goal of the course is to equip you, okay, and to give you comprehensive understanding about various modeling technique, okay, and then how you will do the impact assessment, yeah, on transportation planning, engineering, and about the policy, yeah. I will define it very rigorously so that you will see, oh, this is what is called policy, okay. It's not blah, blah, blah. It's very mathematic. Okay. So now this is the course objective. Okay. So by completing this course, you will be able to apply the transport modeling technique, supply, demand interaction, okay, support evidence-based decision making. Okay. Second, you will be able to evaluate infrastructure, yeah, service intervention. So this is the policies. So you will start to see the systemic impact rather than just certain links, certain policy that you put. Okay? I want you to do system thinking. Okay, and then I want you to see the trade-off between one policies and the others. Okay, and we will define it very clearly. What is the meaning of performance? What is the multiple criteria that you define? Okay, and then of course you will formulate your policies in atom and molecular. What is that? Why we have chemistry here? Yes, we will have that. Okay, I will show you later. Okay, that we can actually put the policy into atomic level and then combine this into molecular level. So your goal is not atomic level, your goal is molecular level. Okay, so and then you will use the ideal traffic assignment framework. This is what I propose to simulate. Anyway, the program is there free. Okay, I have it in JavaScript, in online, I have it in Python, I have it in Excel. In this course, mostly in Excel. Simple. Okay, and the one in the online, I have in transport, you can search in Google. There's also connection to GIS. So you can directly connect to GIS. Okay, so, and yes, I want you to do optimization, not just doing, oh, this is comparing two scenarios and then that's it. No, I want you to do some kind of optimization. Oh, this is the best policy that I have ever made. I want you to be proud of yourself. Okay. Next. So output base. Okay. Well, you can create a software if you want to public domain, or you can publish a paper report. Okay. So, and you will create case study. Okay, scenario comparisons. And I hope you will create certain uniqueness and originality based on this course. Okay. This is the course outline. Okay, today we'll discuss about activity, land use, transportation interaction. Okay, maybe next week we discuss about traffic flow and transport policy analysis. Okay, and mostly mainly we will discuss about demand supply transport system. Yeah, and majority of the course, of course, this part. Yeah, traditional transport model, the four-step model, yeah, FSM, ideal flow network, and ideal traffic assignment. Yeah. And finally, we'll discuss about network optimization. Okay, so the detail, I put it here, including the date, including the test. Okay, every week you will have the quiz and assignment. Okay, so this is the plan. So, but not necessarily we will be able to do this because if you have some storm or you have some certain holiday that I don't know, then you need to tell me. Okay. Any question about this? If you want to change certain things here, you tell me now, and then I can change that. If not, this is our agreement. Okay. So this is the UP grade system. Is that correct or not? So we will use this. And okay, so these are the readings. Yeah, I already put some of this in the reference in Revoledo, so you can search. Okay, except for the first one. Yeah, the first one is still 2026. Okay, so this is my incoming books in Springer Nature. So, but part of this you can I will reveal little by little through the slide. Okay, so this is the course requirement, the breakdown of the mark. Okay, so you will have recitation 5%. This is your own, so you claim it on your own. You see? Okay, the group project is a group, so 40%. Okay, the quiz and assignment 25. Midterm is very small, so if you fail the midterm, don't worry, just 10%. Okay, the final exam is 20%. Is it okay or not? Anyone want to discuss about this? So, yes. Okay, good. So with this kind of percentage, I'm sure everyone will pass with flying color. Yeah, no problem with this. Okay, so no worries about passing, but you worry about your own understanding. Okay, so be present at the meeting. So each meeting will be on time. Okay, so if you are late, you cannot claim the 5% recitation. Okay, please open the camera. Okay, I don't want to talk online with a wall. Okay, so I want to see your reaction so that we can, interact. Okay, so and you can close your mic. Okay, so that there is no interaction, interference in the uh, Zoom. Okay, so please be active in its meeting. Okay, so share your knowledge, share your experience. I'm not always right. Okay, so you can give critics, no problem. You can give suggestion. Okay, and to other groups and to other friends. Okay, so the reason I asked you to introduction in the beginning so that you can create a groups for your group project. Okay, so in the recitation, you claim on your own. Okay, I put there in Moodle. Can you see? Go inside your Moodle. In the top, you can see the recitation entries. Okay, so with what you discuss within the class, okay, or assignment or any case study or your group presentation, or you just talk about anything, okay, that you raise critical question or you answer the question or you give comments, yeah, to me or to other friends, you can claim maximum just 10 points per week per students. So, but of course, Moodle will not allow more than 100 points in one semester. Okay, so even though we have like 14 or 16 weeks, so that's maximum is 100. So at the end of the semester, we will normalize. Okay, so the maximum points of the students, the most active student, will be the basis. Okay, so that means if you one of you reach 100, the others only 15, then you have 15 out of 100 times 5% for the assignment for this recitation. Is that okay? Okay, so how you claim your discussion point every week, please put the date and what was your question, your suggestion, and so on. So what you did in the class. Okay, so just 5%, but this will change between the B plus and B, between A and A plus and so on. Okay, it's very sensitive. So important here, put your total recitation point on the top. I don't want to calculate for you. You calculate on your own, your claim. Is that okay? Next, the quizzes and assignment are designed to test your preparation before the class or the review of the previous class. Okay, it's just 5 minutes quiz. Maybe just one or two questions. It's nothing. Okay, and then the first one is very small. Even the assignment also. Usually the one that you do in the class, okay, practice in the class, and maybe you did not finish, we will do it. Ask you to do it as assignment. Okay, and then mostly about problem solving. Yeah. So, but it will carry Fibonacci weight system. You know Fibonacci 1, 1, 2, 3, 5, 8, 13, and so on. That means, okay, the last one, the last one will be the highest score. Yeah, the first one. If you miss the first few assignment or quizzes, no problem. Okay, but if you miss the last part, okay, the later part of the assignment or the quizzes, it will have big problem. So, okay, so the purpose is to encourage you to do independent study. Okay. So this is the project. This is the 40%. Okay. So this is scenario-based policy optimization to mitigate traffic congestion. Okay. So how can a molecular level transport policy be designed and to evaluate it, okay, to mitigate traffic congestion in the specific urban areas that you can get? Okay. So it's a group project, so 2-3% per group. It's okay. Okay. So you can use the IFN transport in Python and Excel, or maybe you can use GIS. Okay. And then you can simulate the traffic congestion, okay, under various policy scenarios. Yeah. So you start with the base scenario, okay, and then you optimize this model using the ideal traffic assignment principles. Okay. So data is not important. So if you can calibrate the model with the real world data, that is encouraged. But if you don't have data, that is fine. Okay. Don't emphasize on data. We are in modeling class, not data analysis class. Is that okay? Okay. So then you need to design. The most important is you need to design and compare multiple intervention scenarios, yeah, to assess the systemic impact. Yeah, not just, oh, because I add my number of lanes, then it's better there. Yes, it's better there, but how about the induced traffic in other place? Okay, so you need to think about systemic impact, not just in one place. Okay, so in this case, you perform this analysis and then you try to find the optimal, okay, future-oriented policy strategies. Okay, so outcome is paper. Okay, so produce a publishable paper that demonstrates your rigorous scenario analysis, your policy evaluation, and actionable insight. Is that okay? So grouping is up to you. Okay, so you allow 1, 2, 2. You want 3 or 2 maximum? We have 8 students in the class. Yeah, so grouping should be submitted by next week in Moodle. Okay, once you make a group, okay, it's a merit of convenience, so don't divorce, even if you fight within the group. Okay, it's just one semester. Bear with it. Okay, so each member must show the work in the tracking review, okay, and do many round revision. So in each submission milestone, you need to submit, say in MS Word, proving that each member is actually working. So the tracking review should be intact. Okay, so that we will see the date and how they work. Okay. I don't want one member just doing all and the other is doing nothing. Okay, so and then before making the next revision, you can restart the tracking review, accepting all revision. Do you understand this? In the MS Word, there is a tracking review. Okay, you can use that tool. Okay, you want me to show or this is clear already? Give me feedback. Okay, so clear.
Sir,
Yes.
can we also use Google?
Oh yeah, the same. In Google, you can also have the
I think it's easier for our UP mails.
no problem with that. Yes.
Thank you.
Thank you. So for the paper, you just summarize, okay, your report in more scientific way. Okay, your report, you put everything, but in paper, you probably have only a few number of pages. Okay, so this is the usual. Okay. So you have the background, you have the literature review, methodology, analysis, and conclusion. So if you want to put my name, that's fine. If not, that's not required. Okay, but in fact, if you want to put my name, then you need to tell me, okay, in advance so that I will make a critical contribution rather than just putting my name there. I don't like that. Okay, so please make appointment at least one time for discussion. Okay, about the paper, about your project in one semester. Okay. You can book the appointment for the consultation as early as possible. Okay, don't tell me tomorrow. Okay, so I cannot do that. So at least 1 week. Okay. So usually the paper is in whatever journal format that you target. Okay, usually about 8 to 16 pages, double columns. Okay, so you can use cloud service or whatever. So this is the guide for collaboration with me. So you can just check, okay, the policy that I make. Okay, so meaning the basic principle, if I don't have contribution, I don't want to put my name. That's the main point there. Okay. So this is the milestone. So next week, I hope you can start to create. You can use AI. No, I have no problem with that. Okay, so you can create a full report. Just outline probably. Okay, everything you just put, and then after that you continue to do what is called continuous improvement, right? Kaizen. Okay, so by week 8, I hope, yeah, you have at least one alternative scenario that do better performance in terms of efficiency and effectivity than the base scenario. Okay, by doing repeating work, round revision again and again, keep improving, then you will have everything the correct way. Okay, so please read this on your own. Yeah, again, the calibration with the real world data is optional, not it's encouraged but not required. Okay, and okay, so this is how I will evaluate your work in the paper and the project. Okay, so each of this part will have maximum. So if you calculate, the total will be more than this maximum. Can you see? Yeah, if you calculate the total will be more than the maximum. So this is the maximum. It's clear or not? So for example, if you have related background, I will put 2%. Okay, I will check if you have program definition, I will put 5%. Okay, if you have risk objective, you will have 3% of that. Okay, but if you add so scope and so on, so this will be 2% and 3%, but the total is 10, so it will be deducted maximum 10. Okay, but if below that, it will still be that way. So for example, I don't have the scope, I don't have limitation, still 10% anyway. Okay. Okay, the same thing here. In the result of analysis, maximum 50%. That means, I have only optimization 20% result, and I don't have sensitivity. I don't have, of course, you need to have this base scenario and alternative scenario, right? So this alone is 20%. And so this is how I evaluate. I hope this is objective enough. Okay, even within the subjectivity, I have trying hard to make it as objective as possible. Is that okay? Next, so yes, you can use AI. I don't mind with that. So you will do testing together if you want. You can do a prompting in AI if you want. Okay, and yeah, any AI that you want is okay. But at the end, okay, the result must be free from plagiarism and pass the AI detection tool. Be smart in your own prompting. Okay? So meaning, yes, you can use the AI. Eventually, you will be the one who combine everything and revise, isn't it? Okay? I don't want just copy paste from the AI. Okay, so this is done the same. So, this is important note, yeah. All project report assignment cannot go beyond the final exam date, yeah. So, you cannot have late submission. So, if you late submission after the final exam date, automatically you will get failure mark, okay? So, but if you miss some of the progress report, the assignment deadline, because the date is different, right? So then you can submit, okay? But yeah, late is okay, but minus 1% times the number of delay. So if you have 10 days delay, then minus, so instead of 100, you get 90, right? So, right. Now, after the final exam, so give me a few days or a few weeks, and then I will announce to the bidder, okay? And then you will have at least 48 hours before the final grade submission to the CLS, yeah? So you can check your grade. If I make mistake, so you tell me, okay? And then if everything all right, so I will just submit. Once I submit it to CLS, you have no right to protest, okay? Because I already gave you the chance, okay? Say you make a lot of late submission, I still give you 48 hours. Please submit. Is that okay? So with this, I hope everyone pass with very nice grade, yeah? So please be actively participate, okay? And give comments, suggestion, and propose your own idea. Is that okay? Yeah. So any question about this course syllabus? Any discussion about this?
Sir, how
Yeah.
can we group our ourselves?
You want to discuss now within yourself? I will close myself. 5 minutes break, and then you can tell how you group. Is that okay?
Sir, how many students are enrolled in this course?
Total is only 8.
And one is absent today, right?
One is absent today. I don't know who is that. I'll check. So okay. So 3 person per group maximum.
Okay, sir.
Okay. So
And the other, so 3 groups.
3 groups in that case. Is that okay?
So the last group will be 2 members, right?
Well,
Okay.
you can have 4 groups if you want, no problem.
Oh yes, sir. We can have only 2 groups for each.
No, that's bad.
That that's not allowed, sir.
That's bad.
Okay, so we can have
no, two groups in the whole class, eight divided. That means 4 person per group.
Yes, sir.
No, not good.
So we can have
maximum 3 is okay. Yeah.
Okay.
Okay. So I'll give you chance. Now it's 7:06 until 7:15. Is that okay? Let's break for a while, and then you can discuss among yourself.
Okay, sir.
Then come back.
Okay, sir.
7:50.
Okay.
Okay, good. So I'll pause this recording. Yeah, it's good that you have a group. Yeah. So please submit the grouping in Revoledo Moodle. Okay, and then I will assign that into group so that when one of you submit, the others will automatically submit it. Okay. Next. Wait, let's start. Okay, good. Let's start with our first topic today. This is just an introduction to urban planning. Okay, so you can check there in Moodle the slide. Oops. Can you see the slide? Okay, so yeah, very brief introduction only. Okay, so basically a city is a group of people and number of permanent structure within it. Okay, so you organize to facilitate certain exchange in the good of service among the residents and with the outside world. So actually city is very interesting phenomena of human society, isn't it? So people who don't really know each other can cooperate and live in the same place and can interact and exchange. And all of this because of communication and money. Yeah. So very interesting phenomena of human society, which probably monkeys cannot do that, right? So if you compare, okay. So urban planning or regional planning, town planning, okay. So or sometimes rural planning. So it's a technical and political process that is focused on development and design of the land use and the built environment. Okay, that's include everything, yeah, including the environment. So that's including the air, the water, the infrastructure. Okay, so that's also include the transportation, communication, distribution network, and their access. Okay, so when we said urban design, then this is the process of designing and shaping the physical features of the city. Yeah. So right now, if you look at the design of the city, yeah, mostly, okay, in front of the government office, yeah, in any major cities, usually there is some kind of park. Okay, so this is example, the park. So here, so the same, yeah, is in Paris, right? There's a kind of park in the center, yeah. So, but in Japan, they changed that phenomena into eki, into station. So the center of usually the center of the station. Yeah. So this is the city center in Chatwoods in Australia. Yeah, looking towards Sydney. And if you look at the development here, okay, uh, the surrounding area is actually low urban area, and then only in certain part have high rise. Okay. Why? Why this phenomena happen? Why this phenomenon? Yes, please.
Transit-oriented development. There, as you said, the center of the city is in the transport nodes or the train stations, and then the principle there is that there's retail around it, and then the high rises with high
Ah,
density, so that they can maximize the transportation of the train.
is it because of transportation? So what with if you don't design the transportation that way?
As compared to US where they have more
Correct.
cars,
Yes.
so it's more of like it's more sprawling
Hmm.
and yeah.
That's
So
correct. Yeah. But even in the US, Australia, this is in Australia. You see, this is also sprawling, isn't it? But still, they have more development in the city center than the others. If you look at the bird view using airplane, okay, so you go to Manila, it's the same thing, right? So only in certain part It is probably in Ortigas, Makati, will have high-rise buildings. On the others is just flat, like this area here. Okay, so this is automatically happen because of the utility. Yeah? So if they want to go to the center, isn't it? Say example to make it extreme. Yeah, what happen if you create a farm, okay, in the city center to make it extreme? Say you have a farm in the city center, what will happen? It's underutilized, yeah, because the farm is actually cheaper, okay, than business. Okay? So in that case, automatically, okay, people will sell their farmland and then put it into higher utilities, no? Higher. They want to improve their own profit, isn't it? Yes. So in that case, this phenomena happen as self-organization phenomena. Okay. Next. This is the design, yeah, of what is called linear city. Yeah, just one road like this initially, and then they build around that particular road. Okay. And probably in a long time ago, people are starting with this kind of city, linear city, isn't it? So you can start to see they they build the road and then people develop surrounding that road, yeah, while all the other land uses, yeah, for land farm and so on is behind those things. Can you still see this? Yeah, if you go to a rural area, you can start to see. Okay, behind that road, okay, is nothing, no development at all, right? So this is another example of in Quebec, yeah. So linear city, yeah. So behind that is practically nothing. Yeah, this is based on the sea. So yeah, interesting phenomena, yeah, of city design. Okay, and this is Hong Kong. Yeah, look at the road development here in 1915. Okay, and another type of design is grid city. Yeah? So with certain center here, this is in Agora, in Greek, ancient Greek. They built the city based on this kind of design. Okay. Later on, people start to see, okay, this is another example of grid city, yeah, in Elburg in Netherlands, right? And this is another example of grid city in Washington, D.C., yeah, that is in 1792, right? So, again, in Melbourne, it's again initially grid city. From linear, they developed into grid city. Okay, and then this is another example in 40. Yeah, so this is based on Wikipedia anyway, right? So then start to think of new ideas. Yeah, how we develop the actual city design. Yeah. So this is in Slovakia in 1938. You can see the design of the road. Yeah. Flat. Yeah. Yeah. And there is some idea of how if we make it into Garden City, yeah, in 1902. Okay. We created this kind of design. Yeah, I think this is a creative idea that influence people, isn't it? Okay, and based on this idea, then they start to implement, okay, into real city. This is Berlin, envisioned before the war. Okay, and then people start to think, oh, maybe grid is not good. Yeah, why? Because grid discourages public transport, isn't it? Yeah. So then they start to think in terms of circle, yeah, concentric circle, something like this. Yeah? So including Metro Manila, yeah, you have ring road, right? Yeah. So you have uh, concentric circle model, yeah, something. This is in Moscow. Yeah. This is in Kurdistan. Very clear uh, concentric circle design. Yeah. Yeah. And yeah, this is in Kabul. If you look at the design, this is the plan for reconstruction. Yeah. And what happened is, yeah, if you look at the global land use, yeah, the Earth, yeah, surface is only about 29% of the land. Yeah. So out of this, yeah, only a few will be uh, inhabited. Yeah. And then from here, you can start to see that what we use is actually very small percentage, yeah, of the actual land. Yeah. So with that, people start to create a new idea, what is called zoning, isn't it? So this is the example of zoning. Oh, maybe we should start to define, yeah. This is the governmental zone, this is the green space, this is the residential, this is the commercial. Again, all of these are ideas. Why I'm talking about this, that means if they can create ideas and they implement, you also can do, isn't it? Huh? As long as you have the basis and can influence the other, then you have the chance, the same chance as your predecessor, isn't it? Okay. So start to create a new idea of zoning. Okay. I don't know what's the reason of creating this kind of zoning. Okay. Automatically, this is bad. Yeah. Creating this kind of division is actually bad mathematically. Why? This is called minimizing entropy. Okay. What we want is actually mixed land use. It is maximizing the entropy. So because of that, it's create traffic congestion. It's create that kind of urban development that is center in the city center. Okay, and this is example of land use planning in Winnipeg in Manitoba. Okay, so they start to divide. Okay, you can see the legend there. More detail, you can zoom in. Okay, and actually, mixed land use was for 1,000 years, okay, happening. And this kind of zoning is just a few hundred years, okay, compared to mixed land use, okay. And what is mixed land use? Meaning that at the bottom you have some kind of commercial probably, okay. At the top you do residential, so mixed land use. So the same space you create different function. Yeah. Actually, this is better in terms of mobility, right? But because of the ideas, our predecessor ideas that create the zoning, then uh, people think this idea is better, then it influenced our life. Do you get the message? That means if you want to change, you need to create better ideas, better argument, then prove it. Then if this become the common argument for many people, then it will become better ideas for the future. And this is the task of urban planners, isn't it? Of transport planners. I hope you understand. It starts from ideas. Okay, and then you publish these ideas, people interested, and then you implement this. Okay, so the idea of concentric circle with zoning, they can start to combine this together. Yeah, the center here is the commuter zone. Okay, central business district in the middle. Okay, and then factory, and then some kind of transition, and then this is the working class zone and residential at the periphery. Yeah. With this, you have a traffic one-way direction in the morning from Quezon City to Makati, and then going back in the afternoon. Isn't it? Just because of that idea of zoning. It can be avoided, you know. But because you believe in this idea, then it happens. All this problem happened because of certain ideas that we have in the past. And we believe that one is correct, but not necessarily correct after we experience, isn't it? Okay, so again, another idea is, oh, maybe not concentric, maybe we do it sectoral. Okay, we still have the CBD and so on. Okay, so do it in different way. Okay, why I'm talking about all of this, these are all ideas, meaning you can also create your own ideas. You got the message? Okay. Here, this is another idea to put this into different type of nuclear model. Okay. So instead of sectoral, instead of concentric circles, so they start to. Again, all of this idea is dividing. Okay. Remember this. Okay. Mathematically, if you start to divide, then you have minimizing entropy. Okay. If you mix everything, you have maximizing entropy. Okay. Maximizing entropy is the natural way. Okay. The world will go there eventually anyway. Okay, so this is another example of concentric circle in Dubai, sport city, just small part of that. Okay, and the reason that why we have high-rise building in the middle, in the city center, yeah, one of the theory is this one, yeah, bit rent curve, yeah. So utility theory, yeah. So say this is the distance from the CBD and this is the rent price per meter square. Okay. So if you put the land farm in the middle of the city, okay, your utility is too small. So you will be in here. So retail price or residential or manufacturing will be higher. So in that case, you tend to sell in order to maximize your own profit, isn't it? So that's why in the city center, the land price is high. Okay. Look at it this way. If the land price per meter square compared to the construction price per meter square, which one is higher? Okay. If the construction price is actually cheaper than the land price, people will go up, isn't it? People will tend to do maximizing their own profit. So in that, their utility in this case, yeah. So people will expand on top, yeah, because the land price is expensive. So again, this become a self-organizing phenomena, yeah, because of this kind of bit rent curve. Okay, so what is the good things about this kind of street hierarchy? Yeah, this is another phenomena. Okay, they said, oh, in order to make mobility better, we need to create street hierarchy. There is a major road, primary road, secondary road, and then tertiary, and finally the local road. Yeah. So in order to make so that when you are in the major road, okay, and the primary road, you can do faster. And then in the local road, you have access. Okay? That if you do according to this street hierarchy, that means in the major road, you should not have access. Okay. That means if you want to have access, you need to create a local road to separate between the main access and the actual road boundary. Do you understand what I'm talking? I will give you a drawing here. So this is your actual road. Okay. So this is the buildings. Yeah. Here. Yeah. And this is the middle center, right? So if you want to have access, then what you need is to create a separation, right? So that if you want to have access, okay, so you need to go to the local road. You did this, for example, in Katipunan, long time ago, there is that kind of access. Yeah? But one of your mayor who become MMDA head at that time removed that. Okay. Again, because he or his team does not know the meaning of street hierarchy, isn't it? Okay. The purpose of street hierarchy is to create separation of access and mobility, right? So if you are in the major road, okay, you're supposed to have mobility, not access. Okay. But if you are in the local road, you're supposed to have access, because access means parking, okay, going enter and going out of the road, of the house, of the buildings. So, but if you put the major road with the local access, then it defeat the purpose of street hierarchy. You get the idea? Any discussion about this? It's happening because people don't understand the concept of street hierarchy, isn't it? Yeah. Next. Yeah. So in low density, yeah, you want to say something? Anyone?
Sir,
So
what's your idea about our EDSA? Because it's a combination of mobility and accessibility.
exactly that's the problem, right? So you need to separate the accessibility and mobility. Okay. One, because you defeat the purpose. The actual, if you understand the concept, then you do it according to that concept. But if you don't understand the concept and then just implement without any theory, without any concept, this is what happens. You mix up the concept, then you don't even have any direction, right? So your concept in the beginning is to have a ring road, isn't it? You develop it to become a ring road. That means this ring road will become the primary road. Yeah, you call it C1, C2, C3, C4, and so on. Okay, and that's supposed to be primary road. That means you have no access there. That's only for mobility. That means even if you have the traffic signal there, you need to make it coordinated. Supposed to have mobility, not to have accessibility. Okay, but there are certain power that play around because I live there, so I want to have access. Then, because you are powerful enough, you tell, no, we should not do that. And then you start to create mess in your own concept as a society, isn't it? And your leader does not know the real concept, the transport and urban planner doesn't even tell, even if they know, then it's a problematic. When good people do not stand up, okay, then it's a problematic. The same with your MRT. When your MRT is running together with the bus and competing each other, that is funny concept. Anyway, later when we discuss about mode choice, we will discuss that again. Yeah. So this is the urban densities and car use. Yeah? This is in terms of energy, and this is the area per person. Yeah? And you can start to see European cities are at the bottom here, yeah? And US cities at the top there. Yeah? So they're compact. Yeah? So this is a compact city, and US cities are very big. They're different between one and the other, and different between places. Yeah. So nowadays we talk about smart city, isn't it? So what is the smart city? Yeah. So you start to implement sensing devices, yeah, electronic methods to collect the data, to monitor all these resources, and then you improve, yeah, so that from this data you can on time, on real time, okay, manage everything, yeah, from the traffic, from the water, waste, including crime detection and so on. Yeah. So this is, we hope, can solve, through technology. Yeah. But again, you need to understand the theory behind rather than just implementing technology. Okay. So what make a smart city smart? Yeah. So real-time monitoring, okay, probably with the AI, yeah, will help us, yeah, to create a better optimization. Okay. But at the same time, your own understanding on the urban design and urban planning is the actual things that matter. Okay, technology help, but it is you who create the actual things that matters. Okay, because you create the policies. If your policies destroy all of this concept, then even if you have the best technology, you will not get better outcomes. Okay. So next, we discuss about growth. Yeah. So smart growth in urban planning and transportation, meaning we want, if possible, to be compact city. Yeah? We want to avoid the urban sprawl. Okay. We want to make it trans-oriented, walkable, bike friendly. Okay. so that people can go to their school walking or biking rather than using car. Okay, so in that case, this is our goal. We need to come back to what is called mixed land use development, with a range of housing choices. This is our goal. We make mistake in the past centuries. Okay. So then we need to come back here. Okay. This is our smart growth. Yeah. So with the compact city, yeah, we'll have more space for greeneries. Okay. For pedestrianization. Okay. What make a city is not just a buildings, no, but how we will make the city livable. Yeah, livable city. Okay. So, okay, so this is next topic. So is there any things that you want to discuss about those concepts? Yeah, I'll make it very brief for everything. Yes, please.
I want to share a case study of the Makati City.
Okay. You want to
So Makati,
share screen or
yeah,
no? Yeah, okay. I will stop.
yeah. I just want to share the Makati zoning
Yeah.
because the main roads there, I think they apply also they limit access to the main road. I think that's one of the reasons why Makati City is somewhat more successful than BGC in terms of managing traffic.
Hmm.
Because the main roads in Makati, not sure, Prof, if you visited Makati, but
Hmm.
there's it's a triangle, and those triangles they limit access to the buildings. So they have barriers uh in those this triangle, and the
Hmm.
zoning is that you can only go behind
Yeah.
and then
So
access.
they limit the access.
So so when I first read that in the zoning ordinance, I was like, oh, this is unique to Makati. Like I've never read this in another city, and um so and it's I'm not so sure. Like also it's there's lots of access. So it's interesting that it was brought up, and I've never heard of that concept that you have to limit access to maximize mobility.
Hmm. Yes. One other things is pedestrianization. Yeah. So if you look at Makati and BGC example, okay, they have walkway, yeah, all around, isn't it? And many other cities do not have. Okay? And that is the sign of better livable city. Yeah, pedestrianization. Yeah. So when the government start to make the pedestrian walkway smaller or more difficult for people to walk or to cross, then you start to see deteriorating cities. Yeah. In fact, pedestrian, yeah, walkway is very important aspect of urban planning. Okay, when you prioritize pedestrian, yeah, you prioritize people, and eventually it come back to make your city livable. Okay, everyone is pedestrian at one point of time. Even if you use car, you still need to walk from your parking garage to the destination, isn't it? You forget that you are also pedestrian. Okay, so at one point of time, you are pedestrian. Okay, don't think that if you use car, you are not pedestrian. Okay, so if you want to create a civilized world, okay, pedestrian walkway is very important for urban design. Okay. In fact, you cannot have a good public transport without pedestrian walkway, you know. Okay. So what is that for? Even if you have very good public transport without pedestrian walkway, so people will not have access to that public transport, isn't it? So that is first, before you talk about public transport, talk about pedestrian. Okay. Okay. So I hope this discussion will open our mind. Yeah.
Sir,
Yes.
do you
Go.
have an example of smart cities here in Southeast Asia or even in Asia? Can you cite some
So,
example?
uh, basically, I don't have the actual example, but the concept of smart city is okay. Eventually, okay, everything will be automated, isn't it? Okay, so when I discussed with Toyota at that time, we have the project. Okay, they want to have the car that when they go to certain intersection, okay, or then it will be connected to the actual traffic signal. Okay, based on that, so the actual traffic signal will be monitoring the whole traffic surrounding that area. Then it will have a better optimization. This is example. Yeah. So the same thing for the garbage collection, for example. So if certain area have certain garbage that monitor by sensor, okay, then you don't need to wait until certain date. Okay, so the garbage collector will be able to find that easily. Okay, and not only that, they can actually optimize their routing. Yeah, because now not so many anymore. So in the future, when the self-driving cars is already go in, okay, our concept of mobility will change drastically. Okay, so at that time, the sensing device that we need to put on the infrastructure will be much more. Why? Because now you have the connection, the interaction between the sensing device in the road infrastructure and the actual mobility. Yeah. So probably, yeah, this is the concept that's still undergoing. Yeah, in the near future, people don't buy car anymore. Okay, people just rent like a Grab or like a rent car. Okay, so yeah, a few years ago, say Toyota talked about mobility. We are a mobility company. We are not car manufacturing company anymore. So that means the gear is toward that direction. Okay? So this is the meaning of why we need to have installed this kind of sensing device in the infrastructure. Okay? I hope this is clear enough. Okay? So yes, Justin, you want to say something?
I'd like to ask for your opinion on something, sir.
Yes.
Uh, have you heard of the line, the new smart city? That's the concept. It's just a stretch.
Saudi, in Saudi.
Yes, in Saudi Arabia.
Okay.
Do you think that that is an that or that will be an effective like like a benchmark for other cities to eventually follow it?
I'm not sure. Probably, yeah, because uh, the real concept is a mixed land use,
Yeah.
right? And the line is just because their topography or geography, you know, because it's in the desert, right? But at the same time, it's a mixed land use city and compact, right? So this is all based on the actual concept that developed in urban planning.
Okay, sir.
So up
Yeah.
to certain point, this is what I understood, and this is good. Okay, but the line itself, I don't know. Yeah.
Yeah, thank you, sir.
Yes. During my development of IFN and ideal traffic assignment, okay, and I do a lot of simulation, and I found out that actually grid city is better than concentric city, yeah, in terms of mobility, in mathematically at least, yeah, that it will minimize the congestion level to the minimum level. Okay, so later I can, during this semester, we can discuss more detail about that, yeah, when we talk about pre-magic equilibrium. So, okay, so next is about urban growth. This is for property development, some of you, right? So, this is what I did when I was in Japan. So I created a urban growth model. This is one city called Iwaki New Town. Yeah. So, and this in the right side is the actual photogrammetry, and the left side is the simulation. Yeah. So I created the simulation model, and the actual picture is very small like this. Okay, and then I combine all of this one by one. Okay, this is very huge picture actually. Okay. What you see here is a combination of all. And this is different years, okay? And the simulation was able to match, yeah. So this is calibrated simulation. So with the simulation was able to match this kind of urban growth, yeah. Yeah, so you can see, and eventually we are able to predict, yeah, where the development will grow, yeah, in this kind of urban growth model. What is that for? For property development. So if I knew beforehand that the growth will be in this direction, right? So I will buy first, isn't it? Yeah, at cheap price, and then later in a few years I will sell it at a higher cost. So this is the one of the example of the motivation. Yeah. So this is the urban growth model that we developed. So I'm using cellular automata. Yeah. So the goal is from the starting point of the growth, okay, and then we try to identify good layout and maybe some confusing layout of the cities, yeah, to identify is this sustainable or not. Yeah. So we start with historical data, okay. So yeah, this is what I'm doing. So the model is rather simple. It's called cellular automata. That means the whole city is divided into grid. Yeah, something like a cell like this, and then the cell will move around. Yeah, looking for the development that you have, and then examine all the constraint of that, and then implement certain values in that cells, and then we evaluate again. With this kind of urban growth, we can simulate 100 years in just a few seconds. Okay, so that's the and based on that we can create a lot of descriptor. Yeah, based on the descriptor, then we can calibrate. Yeah, so that's the idea. If you have a model, you have certain variables that you can measure the input and the output, and then you can calibrate with the real world data. So this is the actual things that we calibrate. Yeah, based on this case studies. Okay, then this is the simulation that we have. So we start with certain random initial seeds, yeah, before 1980s, and then we simulate that. Yeah. So I have the simulation of that. Maybe wait, I will show you. Uh, Yeah. Can you see this? Yeah. Urban growth simulation. Yeah. So how they move growth over time. Yeah. The vertical axis represent the development. Okay. Yeah, this one. So using mathematics, yeah, using the power of mathematics, you can create your own model. Okay, and then you can start to play with the simulation of that. Okay, that's the main point here. Let's come back. So with that, we can, oops. Okay, so based on the descriptor that you have, so okay, between the actual descriptor and the real developed in the photo, yeah, we measure the same things, and then we can compare. This is example one of the area is the one of the descriptor that we trying to match. Yeah, so trying to match the data and the calibrated, and then you revise the model. Okay. So this is how you validate and calibrate the model. Yeah. So you have the real data and you have the model, and then you move around this model based on the change of parameter. Yeah. So if you know the actual data, then you can have the clue. Okay, what is the actual result? So with this, I hope you understand the big picture. Okay, so the email of Romeo Bertrand is already, I gave to Aaron a while ago. So, is there anything to discuss or feedback on this topic? On plannings? If not, I can continue with the next topic.
I just want to share.
Okay, go.
I think I tried to read your paper on the cellular automata.
Wow, okay.
I didn't understand it.
You-
Yes,
you-
I didn't.
you-
I tried to read it, but then I didn't understand how the model worked. So
oh,
because I was using it for my literature.
okay. It is actually very simple model. Okay, you have a 3 by 3 kernel that you move around. Okay, and compute the where is that one? Uh, the actual model is based on what is called Eden model, so it's not my own. Did I share screen? Okay, so here the pink color here is the kernel. Okay, and this is the yellow part is the actual city. And then you have certain constraints, isn't it? So for example, the constraint are river, mountain. Okay, so you need to put all these constraints. Okay, so you cannot develop on top of river or certain forest or certain greeneries that you have. Okay, and then uh, we have a kernel to compute. Yeah, this pink color is magenta color is the kernel to compute. Okay, and this computation is based on neighborhood. Okay, so if I have these cells here, okay, for each cell, okay, and then I will check is there any constraint? Okay, is there any what is the actual development in this neighborhood? Okay, and from that neighborhood, we create a mathematics to compute the actual center cell here in the kernel. And then we update the actual value in the city. That's all. Okay, so the idea is just that. So this is based on actual image processing. Yeah. So in image processing, we have a lot of this kind of system, okay, which we move around the kernel. Yeah, the kernel can be have different size, like 3 by 3, 5 by 5, 7 by 7, and so on. And then you compute the distance between the actual the constraint and the actual value here, and then you create your own formula to update the kernel. Okay. With that, you can, and then if you apply this kernel to the whole city, then you have 1 year or 1 day or 1 year update. Okay. And then if you simulate this over, say, 100 years, then you can start to see how the actual city growth changes. Yeah. This is just one of the model. Yeah. I hope I answered your question.
Yeah, I understand it a little bit better.
Right. So
Thank you.
the detail are, and I think I have 4 or 5 papers there, about this. 2004 until 2006. Yeah. All my paper are, when I publish, I put it publicly on the website or in their own respective journal, so you can access publicly. Okay. Yeah, thank you. Okay, so now let's go to transportation. Okay, and in this topic, okay, still sharing. So, okay, this is usually I teach this one whole course called Land Use Activity Transportation Interaction. That's 3 units course, but we will compact all of this into 1 hour. I hope this is okay. Okay, so generally, this is the concept of long-term effect of land use activities and transportation interaction. Okay, and then at the end of this slide, we'll discuss about a simple example of demand supply analysis that you will have this quiz next week. Okay, so in general, we have congestion as the main transport service problem, isn't it? Okay, and the other one is actually traffic accidents. Okay, but this is actually two spectrum. Yeah, congestion means you have slow moving vehicles, right? So yes, it will have possible accidents, but that kind of accident in the slow moving vehicles are not fatal. Okay, but when you have less congestion, that means you have high speed mobility. Okay, then the traffic accident will be more fatality. So that's two spectrum, isn't it? Okay. In one way you want slow, the other one you want fast, more depth. Okay. So congestion often be associated with inadequate capacity of facilities. Yeah. My question to you, is there any formula to relate the actual capacities of the road network with the actual demand and the actual traffic congestion and certain efficiency? That you know probably. Is there?
Hi, sir. I think we studied before in the planning tools, the
Okay.
volume capacity ratio.
Oh, what?
Volume capacity ratio.
Oh, VC ratio. That's basically the definition of congestion itself. Congestion is flow per capacity. That is only link-based, not network-based. Right? My question, if in the whole network, say the total volume in the whole network, total capacity in the whole network, and say the maximum congestion and the efficiency, is there any formula or any rule of thumbs or whatever? Okay, search about this, okay, and tell me next week. Okay. Yeah. In fact, I discovered this formula, okay, in my book. I wrote about it, and it's very simple formula, surprisingly. Yeah, but we discuss that next time. Yeah. So there is a formula to relate this. Yeah. So, but please search first about this. Okay. So, aside from congestion and accidents, actually, there is some kind of user cost, isn't it? Yeah. Transportation is not something that you want. Yeah. Transportation is actually a cost, similar to go to doctor because you are sick. So you don't want to get sick, isn't it? So, okay. Transportation is a derived demand from activities. This is very important. Okay? So you don't solve transportation only based on transportation itself. You cannot solve transportation based on transportation itself. You need to think that transportation is a derived demand from activities. So if you solve the activities, you solve the traffic congestion. Okay. So I did survey in Metro Manila many years ago. That the students did the survey, not me. Okay, and they found out that the fare of public transportation is pretty high. Yeah, can reach 100 pesos per day. Yeah, pretty high compared to their income, right? And not including the travel time and the delay to uh, to go to the next public transport. Yeah. So this is high user cost in public transport that make people don't like to use public transport unless they are captive to public transport. Yeah. So, and now this is also another problem. So if the government want to give subsidy for public transport, okay, so this is high facility cost and it has low rate of return, isn't it? So again, this is discouraged for the government to actually develop this, right? So this is a big problem, isn't it? Everyone want to maximize their own utilities, right? So including the government. But if it is a low rate of return, they probably don't like that. So another problem is lack of privacy in public transport. You need to be in with other people, okay, and probably some discomfort because of noise, appearance, smell, yeah, and vibration, and so on. Yeah, and one of the other problem, especially in the public transport, is the reliability, isn't it? Yeah. It's not on time. It's not always available. Okay, and lack of integration. Yeah. So this alone is actually will solve a lot of will help to solve a lot of discomfort in using public transport, isn't it? So say if you use just one card, but I can use this for jeepney, for car, for train, for bus in one card. Isn't that better than every companies actually need to deal with their own card? So in terms of convenience, yeah, this can be done, isn't it? Through coordination. Yeah. So in Indonesia, I can use just one card. I can use this for parking, for tollway, for public transport, and the same thing. Yeah, including in the hospital. Just one card, and this card is issued by the bank rather than by their own companies. So this is possible if you have coordination. Yeah. So transportation problem is universal design. Yeah. So lack of universal design, especially for these people with disability and elderly. Okay. So is transportation problem is also ubiquitous. Yeah. Everyone have a problem with this. Okay. So what else can we say about this kind of transportation problem? When I live in Manila, okay, my children need to wake up 4 o'clock in the morning just to go to school, which is 7 o'clock, right? And they need to travel every day 2 hours for 5 kilometers of road and come back like 7 o'clock in the evening. So after several years of doing so, I feel this is not alive, not living nicely. So then we start to buy a condominium near the school. Okay. So what happened is from ranking 40 in the whole class of 45, okay, after we move in the vicinity of the school, yeah, they never go down of ranking 1 to 5. Okay, that's represent a transport problem, isn't it? Yeah, so they can just walk for 5 minutes rather than traveling 2 hours 4 hours per day. Okay, they have comfortable life because we live near the vicinity of the school. Yeah, so this is also a part of land use problem. So when you have uh, place, yeah, that actually near the activities, right? Then you have livable city. Okay. Yes. Anyone have similar experience? Want to share or so road transport supply is basically almost constant, right? Because that based on the road width or number of lanes, isn't it? But the demand is fluctuating up and down. So there is a morning peak and afternoon peak. Usually this happening in this kind of curve. Yeah, this is the distribution within the day. Yeah, and at certain hours, the demand is over the supply. Yeah, so then the congestion prolong at these hours. Yeah, so but at other time you have unused capacity actually. yeah, especially in the night. So then if you can manage, yeah, well, then the vehicles or the activities that can do in the night can be transferred to different time. Okay, so that this big congestion will not happen. It's possible, right? For example, the trucks, okay, they start to move in the night, or commercial vehicles. Okay, but this is also a vicious cycle, and when the uh, congestion happen, okay, there is a public pressure to increase the capacity. Yeah, so then you said, okay, we need to widen the road. We need to have more road. Okay, but when you increase the new capacity, or the movement become easier. Okay, and because of that, the urban sprawl is favored, and then the average length of movement will increase, and then the number of trips will increase and eventually create a new congestion. Okay, so as long as the number of population and economic growth there, okay, then congestion will recurring, yeah, again and again. Okay, so this is a recurring problem, isn't it? So how to solve? Well, when there is a war, or there is a disease like during the COVID pandemic, then this break, yeah, this vicious cycle break. Okay, but for a while. So the point is actually, can we use this efficiently or effectively? Okay? Because we have unused capacity actually, in terms of time and space, not just time, in terms of time and space. So then if we can utilize this, yeah, more balance, okay, then you will have a better result. Okay. So these are the apparent cause. Yeah. So as traffic congestion, we cannot solve for real in terms of long term, okay, because we expect population to always grow and income, economic should grow, right? But at the same time, we can actually manage, okay, within certain period of time, so that within this period of time, we can actually improve. Okay. So let's see what is the land use activities and transportation interaction. Yeah. So again, I mentioned several times, okay, transportation is actually derived demand from human activities and needs. So please stick in the mind about this. And this is very important. That means it is significant to the socio-economic growth of urban center and in the country in general. Yeah. When we say transportation, it's not just road, yeah, or rail, yeah, but that include waterway, including air transport pipeline, including passengers and good transport. Yeah. So all transportation is a derived demand from human activities. That means if you want to manage transport problems, you need to manage human activities. Okay. So what is the activities of human? Maybe they do transport for working, yeah. They do for vacation, sightseeing, they do for manufacturing and so on. So because of that, we have a derived demand, yeah, whether it is direct or indirectly managed. Yeah. So because of that, we have also energy. Yeah. This is the curve is talking about energy of transportation. Yeah. This is the speed on the x-axis, and then the y-axis is the energy cost. Yeah. Which is the worst performance is in here in this quadrant. The best performance is in this quadrant. Okay. So if you look at the tanker, It has very low energy cost, okay, but the speed is very small. And the supersonic plane is in this best performance in terms of the speed, but the worst performance in terms of the energy. And we are here in the urban transportation. We are here. We are in the worst performance for both. Okay, right? For in terms of energy and the speed. Yeah. So probably you can invent a new way to go to this direction of best performance. Yeah, the different mode of transportation. Okay. So in terms of noise level also, okay, transportation create a lot of noise. Yeah. I hope in the near future, when all the electric vehicles is there, so the noise level can reduce. Yeah. Certain areas near the airport and the noise level is very high. In that case, you probably need to install a double glass in the windows in order to reduce the noise level. Okay. And transportation itself is actually multimodal. When you say, oh, I have different type of mode of transport, okay, or say I'm using IFN transport, which is only for car. Okay, but how about if I want to use bus? Then you create your own network on bus. Okay, and then you add all this network together. And say using GIS, you can combine this. And what is this parameter here? This parameter here represent what is this PCU value, yeah, the passenger car unit value of this each transport. Okay, so this is the conversion factor from bus to car. For example, say bus is a kind of 3 times than car. Yeah, motorcycle is probably 0.25 times of the car and so on. So these are called PCU values. Yeah, this is once you have this, then you can combine all this network together into one. Just one unit, which is PCU per hour, passenger car unit per hour. Is this clear or not? In your project later when you said, oh, I don't have this different networks, then you create your own network, say pedestrian network, bus network, and so on. Then each of these in its certain point of interaction, the transfer point, then you need to change the flow, everything in one unit, so that you can analyze all in one. Is that okay? I believe those of you who already learned GIS, I think this is very familiar. Yeah, this is the layers, basically, in GIS. Okay, so in terms of spatial organization, we have local, regional, and global. So most of the transportation in the road are local, right? So we're dealing with commuting and distribution of the commercial activities, but we can also think in terms of regional. So that means between cities. Okay, so in this case, probably we talk about the bus, the rail line, the highway, and so on. But we can also talk globally within the countries or international. So in that case, we use airport and port, so air and maritime lines. Okay, so yeah, so our discussion mainly in the land transport, yeah, so with this urban and transit systems in this class. Okay, so yes, you want to say something? No? Okay. So look
Yes.
at yes. Anyone? Go ahead. Who? Okay, nobody. So transportation can be divided into this kind of components, yeah. So we talk about the demand side, yeah, and the supply side, yeah. So the demand is representing the people, okay, the freight and the information about that. And the supply side is the network and the actual nodes there, okay. So each node you can think as origin and destination and certain intermediary. So for example, the intersection. Okay. So this node include the terminal. Okay. So depending on the level of detail that you model, that will create different type of nodes. Yeah. And between that, you have what is called friction. Yeah. Friction here represent the cost. Yeah. When we talk about cost in our transportation, okay, we discuss about generalized cost. That means when we say cost, that include time, distance, comfortability, discomfort, yeah, inconvenient, and so on. So when we say friction, that means cost. Yeah. When we say cost, that means generalized cost. Is that okay? So based on that, okay, the flow, yeah, which represent the demand, okay, is the linkage between these components in the transport system. So our challenge as transportation analysts, okay, is actually to intervene. Yeah, how we will create the transport system that being used effectively, yeah, in coordination with other parties, yeah, including the public and private, to achieve the goal of the society. Yeah. Okay, so I highlighted the word intervenes here, yeah, and effective. That means you need, when we said planning, yeah, compare this to forecasting. Okay, in forecasting, you are passive, isn't it? You forecast, that means, oh, you know, the population at that year is certain numbers. Okay, what you can do about it? Nothing. You can only know. Okay, but when we said planning, that means you have intervention, you control. Okay, in order to achieve certain level of population, then this is what you need to do, blah, blah, blah. In order to achieve certain level of congestion, then this is what you do. So you intervene, you control. That's different between planning and forecasting. Yeah, we still talk about the future, right? But different. One is just passively see the numbers, yeah, forecast. The other one is just you need to do something in order to achieve that goal. Okay, the same thing. Both of them are predicting about the future, but one is active, the other one is passive. So in our course, okay, transport modeling, I want you to intervene with certain change, certain policy, in order to achieve certain goal that you want. Okay? So when we talk about transportation, we don't want to talk about just one particular intersection or particular link. Okay, we must think about the total transportation system. Yeah, that means you need to consider all modes of transportation. Okay, and all element, and that include the person, the vehicles, the network, the facilities, including the transport point, the terminals, and so on. Yeah. So this is very important. The part down here. Yeah. So I will highlight this. Yeah. So if you want to create a transportation network, yeah, yeah. So you need to make the transportation network strongly connected. Okay, why? Yeah. And what is transportation network strongly connected? That means from any node, you must be able to go to any other node. Yeah. Then come back home. Yeah. So you need to be able to go home, right? You don't create transportation network that can go to your school or your the mall, and then there is no way to go home. Yeah, this is not transport network. Yeah, important. Yeah. So definition of transportation network, by definition, you need to be able to go somewhere else and then be able to go home. Yeah, that exactly mathematically this is called strongly connected network. Yeah. When you put that into matrix, that matrix is called irreducible. Irreducible means you cannot divide. Right? So this is exactly the meaning of transportation network. Okay. So there are three types of agents, yeah, in transport system. Yeah. One is user, the driver, the pedestrians, okay, the group of people who use the transport system, and then the operator, okay, say the bus owner, the bus driver, the jeepney owners, the jeepney drivers, and the association about this, or and then the government. Yeah. So each of these agent will have their own role. Yeah. So what type of decision can each agent make, and which group control over particular decision? Okay, when it is the time to implement certain action. So let's see. Okay, say when we talk about the user, that means the traveler, the shipper, yeah, the passenger or the driver. So this agent will decide when and where and how and whether that they want to travel or not. Okay, so this kind of group of user, okay, will decide by the location, by the trip purpose, and by socioeconomic groups. Right? The second agent is transport operator. Yeah, so this include the fleet companies, the cooperative. Yeah, in the air we have air carrier, the trucker, including the toll authority, port authority, or highway maintenance agency. Okay, what they decide. Yeah, this agent will decide the vehicle route, the schedule, probably the price, okay, the service they offer, what kind of one vehicle, how many vehicles that they decide, okay, to operate, and the physical facilities that they provide. Yeah, so they are the one who create the supply. Okay, and then this is the next agent is the government. Yeah, this is through the tax and subsidies, okay, and other financial matters, they can influence both users and the operator. Yeah, so this is important consideration. What is the purpose of subsidy and taxes? Yeah, is not to serve the government, but to influence the user and the operator, isn't it? So when the government is self-serving, that means they only tax the people in order to serve their own government employees. This is no longer government. They are mafias already. Okay, so that is not the purpose of government. Government is supposed to govern. Okay, that means you influence through encouragement, subsidies, or through penalties, which is the tax. Yeah, so remember, yeah, that the purpose of these government policies is to influence, yeah, to encourage or to constrain the decision of the other agents, which is the operator and the users, yeah, in the transport system. Okay, so based on this kind of decision, then it will create a lot of impact, yeah, including the job, including the neighborhood displacement because you expand the road, yeah, including the noise level and the fumes and the air pollution and so on, including the travel time and cost. Okay, so now I put these three actors together in one diagrams. Yeah. So you see here we have transportation systems, okay, in the supply, and the activity system, which is the service and the resources, and you have the flow pattern. So the flow pattern is basically the user side here, based on the activities. Yeah. And the top here is the operator side, it is the supply. Okay. You see, and the government side will impact it to the flow. Important to understand is even if you can control the flow pattern, this control is actually indirect, not direct control. Okay. You cannot control when the user will come or use these facilities. Yeah. Okay. So the demand you can only influence through your policies. Okay. So for example, the congestion will affect the road improvement in this operator side, okay? And then it will reduce the economic activities that reduce the activity systems. And because the government ban the trucks, okay, then they can only run at certain hours in the night, for example, then the flow pattern change. Is this clear? This diagram. So you have many transportation options, yeah, through technology, through the network, and so on. So if you want the detail of this, please read the literature I provide in the reference, yeah, the Mannheim. This is very excellent book. Yeah, I don't give you the whole book, but only certain chapter that related to this one. Okay. Yeah, which I get it from the internet anyway. So this is the main part. Yeah, this is the land use interaction, transportation interaction. Yeah, so let's start. You can see the circle here. So let's start from anywhere. Let's say you want to have, say, start from demand. Yeah, so you have certain change in the activities that will create certain transport demand. Okay, so the change in the activity to the transport demand is actually short term. Yeah, because the activity change. So then, say for example, now because of the road, yeah, before there is no road, now have no new road. Okay, then the land use change. Okay, now a lot of people coming, so change of activities, and because of that, so the transport demand change. Yeah, so there are more people coming to this place. Okay, because the transport demand change. Okay, then in the long run, the blue one is the long term. So in the long run, you need to change the transport facilities, okay, in order to cope with that demand. So in that case, you probably change the traffic volume, or you change the direction, or you change the infrastructure that you have. Okay, because of that change, again, you have change in terms of accessibility. Okay, so in that case, because accessibility change, then the land price change. Okay, so this is the key. So the land price change, okay, then it will change the land use pattern. Remember the bid rent curve a while ago, right? So because the land use change, then the activity change, and then again, make a circle, yeah, that the transport system demand change again. Okay, so this transport change in the transport facilities will change the infrastructure. Okay, well, the land use change will change the activities, mainly, yeah. But both infrastructure and the activities will change due to this kind of cycle. Okay, so based on this land use transportation interaction. Now we can put this into numbers. Okay. So now we go to the mathematics of this, yeah. Okay. So to do that, we have what is called demand and supply. Okay, so this is the demand curve and this is the supply curve. Yeah. In the demand curve, the price will go down when the demand is increasing. The supply curve, when the supply increase, the price increase. Yeah. So when you put them together, you have equilibrium. Yeah. So this is the actual price that happened. Okay. So based on this, we can now translate this economic curve into transport. Yeah. What is demand? Okay. Demand means the flow. Okay. The supply means the transportation system. Yeah. So the price means the travel time. Is that okay? So in economic, you have the price, okay, but here represent the travel time. So with that, I will give you numerical example. Okay, so here it is. Okay, say you have the supply in terms of travel time in minutes, the demand in terms of volume in vehicle per hours, and your transportation system is just simple two-way, two lanes road, 10 kilometer. And then you have activities, that depends on the population and socio-economic activities. Okay, and let's simplify everything, just linear model. Okay, so you have supply depends on transportation and demand. S is supply, is a function of transportation and demand. Remember, demand means volume. So the supply means the travel time here, T. Is that okay? And this M and N is the parameter represent the transportation system. So M here is the free flow travel time, and the N here is the congestion effects. So I just put any numbers here. Okay. So and then you have also demand curve. Remember, demand depends on activity and the supply. So our A is activity, S is the supply. Again, I make very simple linear model. Okay, so the volume here represent the demand. Okay, and then the supply represented by the travel time. Okay, and you have the transport activities represented by this A and B parameter here. Okay, so A is the potential demand, meaning even if you don't have any travel times, you still have this demand. And then this is the change of demand per unit time. P is the change, the slope. Okay. Then we put them together into one. So look at this. You have the curve that represent demand and supply, and you have the equilibrium. Simple. Okay, say I plug all the numbers and you have the flow demand of 2000 and 30 minutes. So let's call this F1, isn't it? Can you record this first so that you will not forget? Okay, remember F1, volume and travel time, then you record this. Okay, 2030. 2000 is vehicle per hour, 30 is 30 minutes. Can you record? Is okay? Next. Okay, what happens if we do a new transport system? Okay, so then if you have a new highway is built as an alternative links, okay, then of course the congestion effect reduce. Okay, so in this case the N change. So now becomes 0.05. Okay, so then plug to the number again here in the equation. Okay, then you get new equilibrium. So this one earlier F1, now we have F2, which is 2623 minutes. Oh, a while ago was 2030. Okay, 2030. Now increase, the volume increase, and the because congestion effect is reduced, so you have faster travel time, better. So the new transport actually have impacted to have better result in terms of travel time. Okay, and increase of demand, that means increase of activities, isn't it? Okay, so this is good. So this is the good effect of new transport system. Okay, so let's record this F2, can you? So that you will remember. Then let's simulate. Okay, what happened if we change the activity? Suppose the population and the economic increase. From here, we have new values, okay, that increase the potential demand. So, and then the value of time, increase also, because now become more sensitive due to economic and population increase. This is change of activities. And what happened? Oh, we have new volume. Can you record this? 3, 4, 30, and 27. Okay. So this one is F3 is 3, 4, 4, and 27. What is the route here? The route here is you have the actual demand, F1. Okay, this is the base scenario. And then you improve the road first, right? And then you see the change of activity. So F3 means you change the activities after you change the road. Okay. Now let's simulate. Let's simulate what will happen if you don't have this route. You use another route. This is what if scenario. What happens if the population and economic increase, but you don't have additional highway? This is F4. Can you record this also and then compare? So we use the old transportation system parameters and the new activities parameter. Okay, and this is the actual result. Can you see? Now you have 2,434 minutes. What does it mean? If you have only activities change without transportation change, okay, you have higher congestion, okay, and you have lower activity. And you see, your economic is affected. Simple numbers, isn't it? This is you can do this computation later, after the class you can try on your own and prove this is right or not. Anyway, this is the quiz next week. So let me, yes, go.
A question, sir. So does that mean that we can actually compute um, increase of economic value
Yes.
based on a new transport?
Yes.
Okay.
Yes. If you have the model, you can do it the other way around, right? Yes. So you can check the increase of economic value if the transport change. That's also true. And you can also change what will happen to the land use if the transport change. Yes, of course. Once you have the model, you can do it around. From output to input. Yes.
Thank you.
Very good. So in fact, that actually in the next slide. But anyway, maybe we don't have time. So next week we will discuss about that basic modeling. So I make this summary of all these four numbers. Four set of numbers. So we have the initial F1 here. Okay. So if you passing this route, that you improve the transportation system first and then go here. with the increase of activities, you see you have 27. Okay, and increase of activities. But what happened if you did not do that? Yeah, you will have 34, which is very congested. Yeah, and then this one actually reduce your economic, isn't it? So this is very simple model, just linear. Okay, that actually can help. Okay, so what we learned so far, yeah. So again, transportation is derived demands from human activities, yeah? And this is a simple demand supply analysis that, yeah, gives some ideas, yeah, about the actual basis for planning. So is there any question about this? Oh, we have only 3 minutes left. Let me check if I have my book. Okay. So this is my books on one of the reference. Let me find the examples now related to this one. I think this is in policy analysis. Let me find. This I think in this one. Still in 7. Oh, something is still wrong. Oh, okay. Maybe this is the similar example. Yeah. So any policy, you can put that into atoms, atomic policies. Okay. These are example of atomic policies. Okay. So you can add capacities. That means you increase the number of links, or you can reduce the capacity, or you can add the links or remove links, reverse the direction. You can add node, remove node. You can increase the speed, decrease speed. You can optimize the signals. Yeah, you can add the demand or reduce the demand. For example, congestion pricing is part of this. Or you can temporarily do all of this above. Yeah, these are all atomics. So you can create the symbols. Okay, and then from that you can combine them into molecule. Yeah, that means you can combine with the sequence. So this is an example of the molecular policies. Yeah. So now in certain links that you want, say for example AP, yeah, I want to reduce the capacity and then I want to add more links in this place, and then I can do certain traffic chains and so on. So with this, your policies now become more rigorous, isn't it? Repeatable by others, more precise. Okay, so this is what I hope you can do. Yeah. So let me get certain example. So with this, you can optimize your policies. Okay, and then this is an example. Yeah. So similar to example earlier. So say I have this transport network, say it's simple. Okay, and then now you have a policy to do, the government said add new lane. The policy is adding new lane, whatever the congestion level reach certain critical value, for example, 0.9. Okay, with that, you have the economic model, this one. Okay, the total demand depends on the population and the car and certain economic activities. Okay, and you can project this population growth and car population growth, and these are the policies. If the value is higher than 0.9, then increase one number of lane, yeah, in that road that is heavily congested. And based on this model, right, so you can create this kind of table. Can you see? So this is the population, and this is the year, and these are the total demand in the whole network. Okay, so then this is the number of lane in that simple network. Okay, based on this, we can actually compute the flow, okay, and the congestion, and compute the actual forecast. Yeah, so it will forecast when it will happen in what year. So this is starting in 2030. The base scenario is 2030. Okay, and based on that, you can actually compute, yeah, when it will happen. That problem happen, yeah, which is in 2032. Okay. Imagine you can predict the time, and not only that, you can also predict the space where it will happen. Yeah, it will happen in certain links, yeah, with this FC, certain links with this FC. Okay, so with that computation, then you start to intervene. Say in that 32, you increase the number of lanes. Instead from 2 now become FC, now become 3 lanes. Okay, and then now the new congestion happens. Okay, the new congestion happens, and then you will get, okay, because of that, okay, now there is a improve in that lane, but because of that, okay, that because you change in the infrastructure, so you keep the number of lane increase in this lane, now the congestion happen elsewhere, so induce traffic. Yeah, so the because this one now you can see the congestion shifted to another links. Yeah, possible to compute that way. Yeah, and then based on that, now you can also predict when this these two links will become congested, yeah, 0.9. So you can calculate that it will happen in 2039, for example. Okay, with the same things. Now, what happened if the model, the policy change, instead of reactive, waiting for problem to happen, we do proactive policy. We forecast first, and then we actually intervene first, not waiting until 2032, but we do it in 2030. Okay, because we know it will happen. So then you can compute again, the same thing, and eventually you will see the same problem happen, but you can have delay of 9 years. Yeah. Okay. So you can have, when you do proactive strategies, which require more early capital investment, but you will have delay of reaching that traffic congestion in from 2030 to 2039. That's mean you have delay of 9 years until that happen. So this is what I want you to do, similar like this, but in the real. Yeah, this is just simple network that I make it up, but you can do it in the real world. Do you understand the task of this course now? Yeah, you simulate in order to know what is the best policy in terms of time and space, what kind of intervention you need. So is this interesting enough? I don't know. You tell me, you give me the feedback. Yeah. So thank you for today, and see you next week then.
Thank you,
Yes.
Prof.
Thank you.
I hope this is
See
exciting.
everyone.
Thank
Yeah.
you.
Yes, thank you.
po.
This is a very
Oh, you
very
don't want to
interesting,
respond. Okay.
yeah, very interesting course. And I think I can see the applications not only for
Uh,
the increase in the mobility, but also the justification for policies.
yes.
Because
Uh,
that's something that I believe.
Exactly, that's the point. Very good, yeah, observation. Because right now, okay, the government is doing policy based on superiority complex of the leaders. Yeah, they think this is good, then they implement directly without simulation. They do directly simulate on the real road, which is based on public money. Okay, this is bad. We should not do like that. Okay, we need to do it in the computer first, compute it until we find the best optimum policies. Then we implement in the real world. Okay, not spending public money for experimenting congestion in the real world without modeling. That's exactly the point of why we need to do this transport model. Okay, I hope this is useful. Yeah,
Well,
thank you. Bye bye.